We are dealing with the 13th problem in this series, and the 13th problem is problem number 1.134. So the problem is stating a body of mass m is pushed with the initial velocity v0 up an inclined plane set at an angle alpha to the horizontal. The friction coefficient is equal to mu. What distance will the body cover before it stops, and what work do the friction performs over this distance? So if we consider this problem this way, that this is the inclined plane which the problem is talking about, and this inclined plane is inclined at an angle alpha to the horizontal. The block is of mass m, and if we break the forces, then this is weight mg in this direction, mg cos alpha in this direction, mg sin alpha in this direction, normal reaction force in the upward direction, and it was given an initial velocity v0 at say this point at the base of the incline. It was given a velocity v0, and then gradually it is rising up. There is a frictional force which is acting to oppose the motion in the upward direction, and we consider over here that as it is rising up, it will cover a distance, let us say s. So let us say that it will cover a distance s. So if we approach this problem, the first thing that we write over here is that the value of normal reaction force is equal to mg cos alpha. Due to this normal reaction force, if we calculate the value of friction, then it is equal to mu mg cos alpha. Now friction and gravity component mg sin alpha are both the forces acting down the incline. So the force acting down the incline, so there are two forces which are acting down the incline, mg sin alpha and frictional force mu mg cos alpha. So both the forces are combined effect for the retardation which will be produced, and m acceleration down the incline is equal to mg sin alpha plus mu mg cos alpha, and therefore the acceleration down the incline is equal to m cancelled out, g sin alpha plus mu cos alpha. So now we say that the initial velocity that is given to us, u is equal to v0. The value of acceleration down the incline we can write, if we write simply in terms of acceleration, then we write it as minus g sin alpha plus mu cos alpha, and the final velocity must become 0 as it covers a displacement s. So if we apply the expression to solve this one, then we say v final square is equal to u square 2a s. We have already substituted a being negative, so from here we obtain that displacement s is equal to v0 square by 2g sin alpha plus mu cos alpha. So now the question is asking us what distance will the body cover before it stops. So this is the first part of the problem, and in the second part of the problem is asking us what work do the friction perform over this distance. Now since friction force is opposing the body throughout its motion, so work done by friction will be negative. So we are writing work done by friction is negative, and it is equal to mu mg cos alpha times this distance, so v0 square by 2g sin alpha plus mu cos alpha. So what work do the friction force perform? So we have a negative sign over here, and if we can just adjust the value of cos alpha so that all the trigonometric terms are in the denominator, so we can write this term as mu m v0 square by 2g1 plus tan alpha. So on readjusting the terms, we get the answer in this format. So this is the answer for the problem 1.134, which is also the 13th problem in this segment.